G'day guys, Socket here. Today we're going to continue on with our car amplifier series, and in today's tutorial we're going to take a look at battery voltage versus amplifier output and how that can affect the level of bass and the loudness that you can get out of your system. So today we're going to take a look at the car's electrical system, how many volts it should be producing, the difference between what we call regulated and unregulated power supplies on amplifiers, how to work out how much maximum power an amplifier can put out at different voltages, and how to get that information off the amplifier's technical sheets, how to check your electrical system to make sure it's coping when you're running your system sort of full tilt, and how to upgrade it if you need to. So there's a bunch to cover today, so let's go dive on in. But before we get started guys, just a couple of little words on safety, because we are going to be playing around with the car's electrical system and we are going to take measurements while the car is running. So just be careful around the battery and stuff, that you don't cause a short or anything like that. And when we're taking measurements with the car running, just make sure that the handbrake's on, the wheels are chocked so that the car's stable, it's not going to roll around accidentally, and work in a well ventilated area because of exhaust fumes and stuff. So just take a little bit of caution and everything should be fine. Okay, well, your car's electrical system is made up of the engine, alternator, battery, and of course all the wiring that connects all that together. And because we're interested in the car audio system, we're just going to plug on the amplifier and speakers on the end. But this is, basically, as far as we're concerned, the chain that makes up your car's electrical system. Now, the two major components in your electrical system is the alternator, which basically generates the electricity for your car, and the battery, which acts like a big storage device for the electrical charge. Now, alternators come in different sizes and forms, and they actually come in 12 volt and 24 volt formats. We're only going to be talking about 12 volts formats today because that relates to cars, whereas the 24 volt relate to trucks and other big heavy vehicles. Now, alternators generally put out the same amount of voltage, somewhere between 13.8 and 14.8 volts. Sometimes for big SUVs or cars with lots of electrical systems, the voltage might be a little bit higher, but generally that's the range that your typical car alternator will put out. Now that stays stable, but it's the amperage or the number of amps, because amps times volts equals watts, and so the bigger the amps for the same voltage, the more power the alternator will produce. So it comes in different sizes depending on the size of your vehicle and the amount of electrical draw that it needs. But typically a small car will have something like 60 to 80 amp alternator, where a mid-size car or van will have something 100, 110, 120, maybe up to 150 plus amperage on the alternator itself. Now, because the alternator is connected to the engine or driven by a belt by the engine, you can kind of see it here, the amperage often goes up and down with the change in the revs of the engine. So as the engine revs faster, the alternator gets turned quicker, and of course it produces more power, right? So yeah, that's how the quick rundown of how the alternator in your system works. And then if we have a look at the storage or the battery, they come in different types. There is what we call the old lead acid, which is the traditional battery, with lead panels and battery acid and stuff like that we're probably all familiar with. And then there's the more modern absorbent glass matte AGM battery, which is used in cars that have stop-start systems and things like that. That's where the electrolyte in the battery is actually kind of absorbed by fiberglass matting that makes up the battery itself. Yeah, so you often see these types of batteries in cars, and of course in car audio we use lithium batteries as often as backup batteries or things like that, and they're a completely different technology. So just be aware there are different batteries, and you need to not all cars can use AGM or lithium batteries. You need to check what battery can work with your car's electrical system and its electronic components. Not all cars can use all of these different battery types. Once again, we're only going to talk about 12-volt systems today and 12-volt batteries. We're not going to get into electric vehicles and things like that. And a battery that is at rest, not being charged, will be somewhere between 12.8 volts and 12.2 volts. So 12.8 volts is basically fully charged, and 12.2 volts is, a pretty a battery that's almost flat, right? Batteries are measured in what we call amp hours. So this is the number of hours that it can run and produce so many amps. And so batteries, you'll have a look on the outside of the battery and it'll have something like 35 or 80 amp hours or 110 amp hours. So the battery's amp hour is basically the storage capacity or how big the battery is. Clearly, the more amp hours you have in a battery, generally the physical size of the battery will be larger too. So you just got to check the dimensions of the battery and make sure it will fit into the space that you have in your car before you go ahead and buy one if you're thinking about upgrading to a bigger battery. So when the car is running, the engine is turning the belt, which is connected to the alternator pulley. That spins around, creates the electrical charge, which travels down the electrical cables to the battery, and providing that the alternator is providing more electrical current to the battery than is being used by the car's air conditioning and lights and other stuff, then the battery will charge up. So, when you're driving around the streets and things like that, and the alternator is working properly, if you measure the voltage at the battery terminals, it should be around about 14.4 volts, right? And if you pull up at the traffic lights, the revs of the engine drop and, the alternator slows down. And so, at idle, we'll be getting something like 13.8 volts, right? So the voltage when your car is running will go up and down depending on, I guess the revs of the engine and, how many electrical things that you've got turned on and all of that type of stuff. But, we talk about 14.4 volts for when the car is driving, and 13.8 when the car is in idle, right? But if you don't have the car running, of course the alternator is not charging the battery. The battery is supplying all of the electrical energy to the car's electrical system, from its storage, right? And so a battery, if you just measure the battery terminals and the voltage at the battery terminals, it will be 12.8 volts for a fully charged battery. And, over time, as you draw upon the battery, the voltage will continue to drop until the battery is pretty much flat, below 12.2 volts, right? Now, how long that will take to flatten the battery depends on the size of the battery, how many amp hours it is, how much storage capacity it has, and how much electrical draw that you're taking on the battery. And we looked at how to calculate all of that stuff in part 2 of the Amplifier series. Well, that's great. I'm probably not telling you anything that you didn't already know, but what has that got to do with amplifiers? Well, that's because most amplifiers' maximum output will scale with voltage. So what that means is the voltage coming from your battery going into your amplifier, if that goes up, then the maximum clean output from the amplifier will also go up. And if the voltage on your battery being supplied to your amplifier goes down, then the maximum clean power that the amplifier can supply goes down as well. Now, this doesn't mean that you can just throw unlimited levels of voltage at your amplifier and get kind of free output. Doesn't really work like that because the amplifier is limited by its design characteristics, how many volts and amps it can handle, and a bunch of other things. But the takeaway here is that your amplifier's maximum voltage or maximum clean voltage, where it's not clipping, will go up and down with the voltage that it's being supplied by the battery. But socket, surely we have diodes and capacitors and all of these types of things in our amplifier that is controlling the voltage. How can the voltage from your battery be actually affecting the voltage on your amplifier rails? Well, that's because all of those different types of components smooth out the power supply, but they don't actually control the voltage itself. That is the job of this little chip that we've looked at before called the pulse width modulator. Now, if you want to know more about pulse width modulators and how they work, we covered this earlier in the amplifier series, so feel free to jump back and check that out. But it's what we call the duty cycle, the amount of time that the transistors supplying the transformer or the power supply section of the amplifier are turned on and off. That switching process that the pulse width modulator controls. In some amps, that duty cycle, that on-off switching, can be adjusted on the fly, and in some amps it can't. So in some amplifiers, they have a system to monitor the incoming voltage, and depending on that voltage, they can then modify or increase or decrease the pulse width modulator's duty cycle, and that makes sure that the voltage rails or the maximum clean output of the amplifier is always the same amount regardless of the voltage coming in, and we call this a regulated power supply, right? So let's say we have the car running and the battery is putting out 14 volts and the maximum output is 130 watts per channel, and so the pulse width modulator might be running at 18 kilohertz or 18,000 hertz, and so we're getting 130 watts maximum out of the amplifier, right? But let's say that the voltage drops. We pull up at the traffic lights and the voltage drops to 13.8. The monitoring system will pick that up, increase the duty cycle to 20,000 kilohertz, and so maintain the maximum output from the amplifier at 130 watts. And then let's say that we decide to stop the car and just listen to the car while we're waiting to pick up the wife from the railway station or something, right? So the car's running on battery power at 12.8 volts. Once again, the monitoring system steps up the duty cycle on the pulse width modulator to make sure that we continually maintain that 130 watts per channel maximum output, right? And so this is how a regulated power supply works. But in many amps, they don't have this monitoring system, and the pulse width modulator is basically fixed, right? The duty cycle is fixed. So, it's always 18,000 hertz, regardless of how many volts are coming in. And so, if we're driving around and it's 14.4 volts, then we're getting that 130 watts of maximum output from the amp. But when we stop at the traffic lights, that will drop to 13.8, and now we're only getting 120 watts of maximum output from the amp. And if we're sitting in the car park listening, with the battery being supplied by battery power, then maybe the total output's going to drop to 105 watts, right? And this is what we call an unregulated power supply, or an open loop, where the maximum output of the amplifier scales with the voltage that's supplying the amplifier itself. So guys, it's important to note that we are talking about the amplifier's maximum output. It's not that as voltage changes happen in your car's electrical system, that the speaker volume will go up and down when you're listening to it normally, because we're generally operating the amplifier well below its maximum output, right? And so we don't really notice these voltage drops. It has very little impact on the system when you're just listening to it normally. But if you're really cranking your system, or if your electrical system is weak, then the voltage drop and can cause your bass and your volumes to sag, problems with, for example, your headlights dimming, or tail lights or other lights in the car flickering, And in extreme cases, the amplifiers themselves might shut down and go into protection mode because the system simply isn't providing enough current to maintain the voltage that the amps need to operate. So yeah, it's important to know that this happens, and it's important to know whether you are using an amplifier with a regulated power supply or an amplifier with an unregulated power supply, particularly when you're thinking about which amp to buy, because you might be spending money on what you think is a 200 watt output amplifier, but what you may not realize is that under certain conditions, that amplifier won't be producing 200 watts, because if it's an unregulated power supplied amp, that output, or that maximum output, will drop as the car is idling, or if you're in demo mode, running the system off the battery. So I guess, how can you tell whether you have a regulated or an unregulated power supply? Well, let's go check out some amplifiers. And the first one we're going to take a look at is this little kicker CXA360.4. So if I head over to the website, this is a 360 watt 4-channel Class AB amplifier from Kicker, and you can read all about it. I can't see anywhere where it talks about regulated power supply or switching, switching controlled power supply or anything like that that would suggest that it's a regulated power supply amplifier. But what we're interested here is the power specifications. So here it's got listed 14.4 volts, 4 ohm, 65 watts per channel by 4 channels, right? And then 14.4 volts, 2 ohms, 90 watts per channel across 4 channels. So as we know, 14.4 volts represents the best case when the car is driving around the streets and all of that type of stuff under full charge. So, my guess would be that you won't get the same level of output if the car is idling, and even less when the car is being driven just on battery, your audio system's being driven just on battery power. So, you just want to be aware of that stuff when you are checking out the power levels advertised, on these amplifier websites. So the next amplifier we're going to take a look at is the JL Audio HD 600-4. Now, once again, if I go to the website and I pull up the owner's manual for this amplifier, it's a 4-channel Class D amplifier. You can read all the stuff about the amplifier and but what we're interested is the specifications, which are way down here at the bottom, page 9 of the manual. And what it says, you can see here, Class D switching type with single cycle control technology. Power supply is pulse width modulated regulated switching power supply, right? So it says here pretty clearly that this will be a regulated power supply amplifier. And you can also see down here, where we're looking at the power rating, it is rated at 150 watts RMS on 4 channels, from 1.5 to 4 ohms, from voltage range 11 to 14.5 volts. So that means, regardless of whether the voltage is 14.5 all the way down to 11 volts, it's always going to put out 150 watts RMS, right? And if it's bridged, then, same thing, that's 300 watts RMS. So, that's pretty clear that this amplifier is a regulated power supply amp. Okay, well, let's look at something a little more modern. So this is the Helix C4 amplifier, once again a 4-channel amp. Once again, if I head over to the website and I check out the features, it talks about down here regulated DC to DC switching power supply with stop-start capabilities, right? So this is clearly a regulated power supply amplifier. When we have a look at the outputs, once again, It doesn't state the voltage because it's a regulated power supply. It's putting out 150 watts at 4 ohms across 4 channels, 220 watts across 4 channels at 2 ohms, etc., etc. And if we scroll down, it says the operating voltage down here is 9 to 16 volts. Okay, so what this would suggest is that anywhere between 16 volts and 9 volts, it's going to able to scale the duty cycle on the pulse width modulator to maintain this maximum output per channel. So yeah, that's the Helix C4. And finally, I've been helping Barrett out on the Patreon channel, who's having a bit of trouble getting his gain settings on all of his amps and DSP and stuff. And he uses these Museway amplifiers, which are not well known in Australia. I'm not even sure they're available in Europe, but he lives over in California in the US, and so he's using these amplifiers. And so I thought we'd take a quick look at these as well. So once again, just heading into the Museway website and pulling up the owner's manual, and we can just scroll down to the technical section, and once again a 4-channel D-class amp, no mention of regulated power supply or anything like that. But what gives this away as an unregulated power supply is the manufacturer is actually quoting, and I'll just zoom in a little bit, the power supply in 14.4 volts and 13.8. So at 14.4 volts at 4 ohms, he's going to get 130 odd watts per channel. And when it's at 13.8 volts, it drops down to 120 watts per channel. So at least this manufacturer is showing the outputs for both when the car is driving and when it's in idle, right? But once again, this unregulated power supply amplifier will probably have lower outputs, maximum outputs on the amplifier when the system is running just on battery. So you should now be able to work out if your amp has a regulated or an unregulated power supply. Now, it doesn't mean that one is better than the other, it just means that they have kind of different features. But this is important when you're buying an amplifier, because often we'll just look at the manufacturer's website and look for, how many watts per channel would the amp put out. We don't always consider whether it's a regulated or an unregulated power supply, or that the maximum output numbers might change with changing voltages. So, we already had a look at this before. This manufacturer, this Kicker amplifier, the manufacturer is advertising the power outputs at 14.4 volts, which we know is the voltage when we're driving, right? But of course, these outputs, or maximum outputs, are going to be lower when the car is idling or when you're demoing the system with the car turned off and just running off your battery. And also, the manufacturers are not going to list their maximum outputs when the car is turned off. And the main reason for that is battery voltages can vary from car to car. With a good battery, you might be putting out 12.8 volts. With a battery that's a little bit older, it might only be putting out, 12.4. So the output on the amplifier is going to change, or the maximum output is going to change, I should say. So you'll typically find that your outputs are always going to be when the car is driving or idling, and some manufacturers like Museway actually list the outputs for both stages, right? And then of course we have regulated power supply batteries, where that really doesn't matter because the power supply or the pulse width modulator duty cycle is adjusted to take in account the different voltages that are coming into the amplifier. So the output, or the maximum output, is always going to be the same on the channels, regardless of whether you're driving or demoing the system, just driving it straight off the battery, all the way down to, in this case, 11 volts, where the battery is basically flat. So guys, when choosing an amplifier, you want to just take these things into account. Is it a regulated or an unregulated power supply? What is the manufacturer telling me about the amplifier in the specification sheets? Is those outputs quoted? When the car's driving around, will it be different if I'm, just running the car off the system off the car battery? You just need to keep all that in mind. But when you are buying an amplifier, always buy an amplifier that has more headroom than the speaker needs. Now, what I mean by that is, let's say I have a speaker that is 150 watts. Then I probably want an amplifier that's 25 or 30% more power than the speaker needs, and we call that headroom. So for a 150 watt speaker, I probably want an amplifier that's putting out a maximum of 200 watts, right? And the reason for that is for twofold, right? So first of all, because it means that the amplifier is not working flat out, 200 watts or 150 watt amplifier matched to 150 watt speaker means that the amplifier's got to work super hard all the time, right? Particularly when you're driving it hard. Whereas if it's got a bit of headroom, then it's going to cruise along and just be a little bit happier. And the second reason is because if I'm got a amplifier with a bit more headroom, if the voltage does drop and it's an unregulated power supply amp, then I'm going to have headroom for that voltage drop and not affect my maximum output to my speakers, right? And just keep all my speakers happy. So you've installed some amplifiers, it's hooked up to your system, all of that type of stuff. So how do you know if your car electrical system is keeping up? Well, generally there will be some signs. As I said, under normal listening levels, this is not normally a problem. But if you are noticing that the bass volume drops off, or you're just not getting enough loudness from the system, or your headlights are dimming, or other signs that your electrical system's under strain, then maybe you need to check it out. So that's what we're going to take a look at next. So first of all, car manufacturers design their systems to produce and supply enough power for the engines, the lights, the air cons, and all the other stuff that you've got in your car, right? And they're going to be sized to suit the power consumption of the car, not necessarily to cover aftermarket audio systems with big subwoofers and stuff like that. So, if you go nuts and add a bunch of stuff, you might find that your system will struggle to keep up. Now, a great big disclaimer. Cars come in all shapes and sizes, and so do their electrical systems. So, the tests and things that I'm going to talk about and the voltages and things that I share with you are guides only. If you have an electrical vehicle like a Tesla or a truck or something like that, then these are not going to work for you. Now, I'm going to be talking about general ranges and stuff. Because cars come in so many different varieties, it's not going to be an exact science, but it will give you a general idea. But if you're in any doubt at all, go and check with your local auto electrician or mechanic. With that said and all out of the way, let's go take a look at how you check your electrical system. So the first test that we're going to do is to check the health of the battery. So all batteries are consumables. They all have a finite life. For a standard old car battery, that might be, 3 to 5 years. I know people have got like 7 to 10 years out of a battery, right? Super lucky. But when they're nice and new, they'll hold their charge pretty well. As they age, they'll discharge a lot quicker. But taking a measurement of your battery voltages will give you a bit of an idea of what state that they're kind of in. So what we're going to do is, first of all, we're going to turn off any electronics in the car. So that's air conditioning, fans, any lights. Shut the doors to make sure that there's no chimes and other things going off. That is putting a drain on the battery. We want to turn off as many electrics as possible. Then we're going to take our multimeter and we're going to measure the voltage between or across the positive and negative terminals in direct current voltage, right? So the battery is in direct current, not alternating current. So if you're unsure about that, go and check out the gain setting video. We talk about how to use multimeters in that tutorial. But okay, so once you've measured that DC voltage, we're going to take a note of that, and generally you should, as I said, these are just guidelines, but a well-charged battery in good health is going to be about 12.6 to 12.8 volts, right? Anything below that means that when you're looking at a battery that's fully charged, if it's only holding 14 to 12.5, that's still okay. It's not perfect, but it's still in pretty good shape. Once you get down to 12.2 to 12.3, then okay, your battery is kind of borderline, and below that, it's pretty much past its prime, right? And you want to be considering getting it checked out and maybe replaced. Okay, so let's go out to the little Audi and let's have a look at the health of the battery in that car. Okay, so here we are. We're going to take the measurement of the voltage of the battery at rest. So the little Audi A1 is turned off. We've got the battery down here in amongst the amps and the wiring and all of that stuff. So I've got my multimeter here. I'm going to turn it on to voltage DC, which is this little straight symbol thing there, and you see on the dial it's got voltage DC on it, right? So pretty simple. We simply attach our probes. So I'm going to attach the negative probe to the battery and the positive probe to the battery, and there we go. And let's have a look at the voltage reading. So 12.68 volts looks pretty good. So the next thing we're going to check is the alternator and the whether it's charging the battery correctly or not. So the way we're going to do that is we're actually going to measure the DC voltage on the battery while the car is idling, but with all the electrics turned off. So in other words, you want to make sure the fan and the lights and all this other stuff are still left off. Start the car and just let it idle. Make sure the handbrake's on, the wheels are chocked so it's not going to move and or anything like that while you're doing this measurement. But then you just use your DC voltage across the battery terminals. Make a note of it, and what we do is we're just going to check the voltages, right? So a healthy alternator charging a battery should be somewhere between 13.8 volts to 14.4, maybe a little higher. Certainly if it's 16 or 17 volts, that could indicate a problem with the alternator as well as in terms of overcharging. But for a standard car, somewhere in that range. Now, if you've got a fancy modern car with what we call a smart charging system, sometimes they throttle back the alternator charging when the battery is full. So, you might find that your alternator charging is 13.2 to 13.8 volts, something in that range. But if your alternator is struggling to deliver 13 volts, 13.1 and below, then there may be something wrong with your alternator or wiring or something, and something that you might want to consider getting checked out. So once again, let's pop out to the Audi and take a measurement of the battery health or the alternator charging voltages just with the car idling. Okay, so the next test is to check the charging voltage with no electrics on, with the car idling. Okay, so just going to go and start the car. Alright, there we go. We've got the car idling and nothing turned on, and 14.4, jumping around a little bit, but 14.4. So yeah, looking pretty solid. So the next test we're going to do is to test the alternator charging with the a bit of load on the system. So we're going to continue to let the car just idle. We're now going to turn on the aircon, headlights, some fans and stuff, just to put some load on the electrical system, and then we're going to measure the DC voltage across the battery terminals, and this should tell us the health of the alternator once we've put a bit of stress on it. So once again, we'd expect to see the voltages not change very much. So let's go out to the little Audi and do this test. Okay, so I've got the car just idling along now, ready to do the test of the charging system when we put the electrical system under load. So I'm just going to pop around the front and turn on the aircon and a few other bits and pieces and see what type of reading we get. Okay, so I've got the aircon running, headlights and things are on. So you can see that you know, it's certainly pulled it down. It's looking like it's at 14.3, bouncing around a little bit, but yeah, certainly much higher than 13.8. So yeah, okay, happy days. So this is where it starts to get fun. We're actually now going to test the electrical system with the audio system playing, close to its maximum output. And so what we're going to do is we're going to turn on the electrics, air conditioning, headlights, fans and stuff. So we're still going to have that load on the electrical system. We're going to start the car and just let it idle. Then we're going to play either a bass heavy track on a loop or a 60 hertz tone at about 80% of the audio system's maximum volume, right? And then we're going to measure the DC voltage across the battery terminals and just see how it turns out. Now, what we do expect is for when the bass notes get hit, we would expect the voltage to drop and rebound if the system is healthy, because the bass is going to draw a lot of power, and of course the system's going to take a bit of a hit. But if it's in good shape, that voltage will return somewhere between the 13.5 and 14.4 mark. If it doesn't and it stays low or it sort of creeps down into the 12, under the 13 volt mark, then that would indicate that the system with the audio system playing bass heavy tracks is really starting to struggle. So let's go out to the little Audi and do the test. Okay, so for this test we've got the car idling. I put my rear sub back in, and I've got a tone generator here playing 60 tones, 60 hertz tone I should say. It's running at about 4.5 volts, 4.56. And well, up the front there, the volume knob's turned up about 80%, 90%, and we're going to hit the little tone now. And 14.4. So it dropped there when we first hit the tone, and the subs were pulling on the system, but it rebounded at 14.4. So I would say that yeah, this system is handling this car audio system just fine. So that's all the tests complete. You could do one more where you turn off the car and you play your system at 80%, and you want to see how long your battery will last without the car being on charge or having it on a battery charger or something like that. You might start out at 12.6 volts or something, and as you play your system, you'll see the voltage slowly dip away. Now, that is certainly something you can do. I would certainly stop that test if you sort of start approaching 12.4 volts or something like that, because you might find that you drive your battery so flat that you can't get your car started again, right? But it's another little test that you could do to work out how long you could demo the car with the car being turned off, to your friends or whatever. I'm not going to cover that in this tutorial. I think it's something simple if you really want to do it. But that brings us to the end of those tests. Hopefully your car electrical system was able to keep up with your car audio system, and everything's fine. But if it didn't, or if you just want to upgrade your electrical system, then we're going to take a look at that next. So depending on the results and what they were sort of indicating, you might want to increase the capacity of your electrical supply system in your car. Maybe a bigger battery, maybe a bigger alternator, maybe you need to increase the size of your wiring, maybe there's just a fault that needs to be fixed. Now, once again, there's a lot of things that you could do to increase the capacity of your electrical supply. Not all cars can fit bigger batteries, not all cars can put in bigger alternators. So this is once again just a general guideline, guys. But certainly one thing that you can do is to install a bigger alternator. Now a bigger alternator will give you more power, more amps, and allow you to have more grunt in terms of supplying power, while the audio system or the electrical system components in the car are drawing on the battery, right? A bigger alternator will allow it to keep up because you've got, remember, the alternator is the power supply. It's going to, a bigger power supply is going to be able to deal with the electrical drain that the audio system is placing on the system, when it's cranked up and all of that stuff. So, you might go from an 80 to 120 amp alternator, right? The other thing you could do is put in a bigger battery, right? If you're finding that your battery's running down too quickly, or you just don't have enough electrical storage, you'd like to demo it with the car turned off so people can really enjoy the detail in your music without the engine running, then maybe you need a bigger battery or a second battery or something like that. Now, a bigger battery won't have higher voltages. It'll just have more storage capacity, so you can run the battery kind of longer, right? And then there's different types of batteries. So your traditional battery versus an AGM battery, the AGM battery will recharge a lot quicker. If you're using or want to use a lithium battery, not all cars will work with lithium batteries. They are very sensitive to how they're charged, and all that type of stuff. They're certainly much safer in terms of fire risk and things than they used to be, but you really need to do your research if you're considering putting in something like a lithium battery. The other thing that you might find, that particularly when you're doing upgrades, is that it might have something to do with your wiring or cable. Certainly if you're doing an upgrade and putting in a bigger alternator, you'll probably need to upgrade the wiring to handle the extra load. Maybe you're using a 4-gauge power supply from the alternator to the battery. Maybe you'll need to run a second strand of 4-gauge wire, or upgrade the wire to a 2-gauge. But certainly something to do with taking all that extra power down to the battery. You may require a wiring upgrade, right? And so generally that looks like upgrading the wiring from the alternator positive terminal to the positive terminal of the battery. Also the battery negative terminal to the ground chassis. You might want to find that you have to upgrade that from 4-gauge to 2-gauge. And the engine block to the chassis often needs upgrading as well. And so we called these 3 wiring upgrades the big 3 upgrades. You might have heard of that before. So regardless, guys, these, as I said, are just guidelines. These are the typical things that you would do if you were going to upgrade your system, either the alternator, the battery, and then generally the wiring. The wiring is called the big 3 upgrade because you've got to upgrade these 3 things. But in all case, unless you are sort of qualified to do this type of stuff, it's best to seek some professional advice to ensure that you're getting the right equipment for your car and your needs. So guys, if you're having problems with low bass, not enough volume when you crank your system up to max, it might be that your amp's not putting out the watts that you think that they are, or maybe it's just that your electrical system is struggling to keep up. Well, at least I hope that this tutorial has allowed you to have the knowledge to be able to check your amplifiers and power supplies and decide whether there's a problem or whether things just need an upgrade. So there you go, guys. That brings us to the end of today's tutorial. I hope you found that interesting. If you've got comments, questions, or anything at all, as always, throw them down below. I'll get to them as soon as I possibly can. Thanks so much for watching, and as always, I will catch you in the next episode.